The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Good morning and good afternoon. Thank you for joining us on this Tuesday with SolidWorks. As you know, and every Tuesday, we are conducting a webinar. It's a series of webinars. So the main goal from this webinars is to listen from you. Actually, we need to be connected with you. So please feel free to ask your questions. Even we can open the mic for you, unmute yourself at the end of the session or even during the session to have a voice conversation. So please do not hesitate to ask your questions. Even during the session, we will be having some poll questions just to participate in this webinar. Last webinar, we have been speaking about SolidWorks portfolio in general. So how can we do the whole thing from design to manufacturing? Actually, today, we will be focused more into manufacturing. And we have a very special guest as a presenter. He's coming from CAMWorks, our authorized reseller in the Middle East. CAMWorks, they are engineering solution provider. They have more than 4 elite application engineers, mainly based in Egypt. However, they are serving the whole Gulf area. So, and today webinar, we have Mahmoud Alkaluby. Mahmoud Alkaluby is a senior application engineer working for CAMWorks for more than 3 years now. And he will be with us today to speak about SolidWorks CAM and how can we bring the design to manufacturing. So let's hand the stage to Mahmoud. And the mic is yours, Mahmoud. Get to go now.
Good morning and good afternoon. This is Mahmoud Alkaluby, Senior Application Engineer in CAMWorks. And today we are going to talk about SolidWorks CAM. In the beginning, I would like to give a briefing about SolidWorks CAM. It's a CAM application which is embedded in SolidWorks. SolidWorks CAM comes in 2 packages, CAM Standard and CAM Professional. CAM Standard comes for free for the customers with active subscription. Also, SolidWorks CAM is powered by CAMWorks, which means if you are a user of CAMWorks, then you won't have a problem with SolidWorks CAM mindset and the feature-based machining concept, which mainly you are going to use in SolidWorks CAM. So in SolidWorks CAM, you have the capability to do the machining part for parts and assemblies. We can also do milling for 2.5 axes, 3 axes, also do turning for 2 axes, and doing indexing for multi-axis machining as well. Which means we can do positioning for the tool with the workpiece using the 5 axes and using the 2.5 milling for the workpiece on the same position. Also, SolidWorks can give you the capability to do something called path simulation or tool path simulation to make sure that there is no problem with your strategies and machining assumption, and to make sure that the part will be machined properly until the results that you require. Also, in SolidWorks CAM, you will find a free library of post-processors to give you the flexibility to export your G code to different kind of microcontrollers of the CNC machines. So in this webinar, I am going to talk in 4 sections mainly. We are going to discuss the process to complete and fine-tune your machine process in 4 sections. So the first section is about the fixture setup, and we are going to talk about a fixture method, which is the vice, and how I can apply it virtually to hold my part to avoid any collision between the vice and the tool. Second process is the part preparing, and I'm going to discuss the tool path and how to generate it using SolidWorks CAM. Third process is about the high-speed machining. And in that section in the webinar, I will mention something called volume mill technology, which is really useful for the machining time reduction. Finally is about the design change, which really show the benefits of the integration between SolidWorks and SolidWorks CAM. We will see the updates which happens in the toolpath due to the modifications which happens in the CAD design. And that section especially is the most challenging step which facing the engineers who are working in the CNC field. So I will go and start with the picture setup. And in that section, I will show you how to use the integration between SolidWorks and SolidWorks CAM to do the picture validation. Also to make sure that there is no problem between the picture device and the toolpath generated to machine that port. So let's start. I prepared a model of the device to mount the port, which we need to perform a machining for it. Using 2D drawing in SolidWorks to show more details for the device and how it could hold the workpiece, and setting up the zero location, the places for dial indicators and the gauges and so on. Now let's start and insert our product. I will go and insert my brackets. It's a mounting bracket. And go with the interface of SolidWorks and do some mate to that bracket, so we can put the machining part in the orientation that we need to machine on it. So it's a normal SolidWorks procedure to mate that component. After I have made that component to my position or the proper position I want to machine for it, I will return to the drawing file to update the drawing. Then I will use something called the property tab builder to add some metadata to my assembly. Let's add some property data like drawing number, like machining type, like whatever we would like to add. We need that property tab builder to update the property of my documentation, so the technicians and the laborers in the workshop have more proper data about my design. When we click apply, we can see how tab builder can update the title block with the data I have just inserted. So that's how I could make the picture for my project. So we have seen the use of the assembly environment to position the machine part in a proper orientation, and also to how to create the documentation using the associative drawing to, like I said, to help the technician with the data and about picture method and the gauges, indicators, and whatever that I would like to provide. The second section is about the part programming. So we have done the part picture, and we are going to talk about the part programming for SolidWorks. After the positioning of workpiece, we will continue with generating the programming lines for the machining workpiece. On the left side, there is a SolidWorks CAM feature tree. I will start with machining definition. As you can see, you can choose a list from a machine from that list, or customize one and add it to the list for further use. The poster processor is automatically assigned. You can choose one from those or browse one from your hard disk, and as per the predefined database, you will find tools which exist in your workshop. Add or remove on that list as per your need. So I am fine with that list. I will click OK. Next step is define the workpiece. You can choose in the workpiece for the machining between one part or multiple parts. So it's a flexibility in that point. Choose the mounting bracket and press OK. And after that, I will go and define the stock. So the stock have 4 options. Either you can select a SolidWorks bar or STL or even a boundary condition. The stock definition is that raw material that you will hold it on the machining the machining device. So the machine will start with it. So after I have defined the block or the stock, I will use a predefined sketch and click OK. Now I'm fine with the stock definition. Now let's see visually How is my setup? Check the zero position, the stock position relative to the vice, and whatever that I would like to check. Now, after I have checked my project, I will proceed with my process. First tool to select is Extract Machinable Feature, which can automatically recognize the machinable places like holes, pockets, and so on. In SolidWorks CAM, I should define a machining strategy. The machining strategy is for each feature. So SolidWorks, if SolidWorks CAM recognized a certain feature to machine, it will automatically put a proper machining strategy for it, and that's from the database. For example, if I'm having a pocket, then the machining strategy will be automatically assigned as rough, rest rough, and finish. Now, after I have made the feature or recognized the feature, I can edit or modify or do whatever I want to my feature manager tree. Now I can delete the unnecessary features from my tree, and also I can make some modification to the feature which I just recognized, and change the depth of the perimeter cutting to be less than the part thickness to avoid any collision between the tool and the device. So SolidWorks CAM can recognize the machinable feature as well from the feature which we mainly or which we previously used in the modeling. So in that point, I have checked the thread callout, which means SolidWorks CAM will recognize a threading operation after the hole or the drilling operation. So SolidWorks CAM will automatically add that thread cutting feature after the drilling operation. Next step is generating the operation plan depending on the feature we just recognized. So SolidWorks CAM will start generating the operation plan according to the predefined setup which we previously made in the database. For example, it said that in the database, when the whole feature is found, then the operation plan for it should be center drilling and then drilling operation, and so on and other features. After setting the operation plan, start generating the tool path to show you show you more about SolidWorks CAM is smart. Now let's check this. There is two kind of holes were machined differently. One by thread milling and the other is by tapping. SolidWorks CAM can recognize it according to the hole size. Still, defining the database is the magic word. One more thing to save cost and avoid more damage is defining the vice component. I'll choose the whole components of the vice which can be in the path of the cutting tool to avoid any collision and failures. Don't forget to use the smart selection tool to save your time. After that, let's do the simulation process to make sure that the toolpath is proper and clean. Good thing about simulation process that it can show you the geometry difference between the original part and the machine part. I will find a big material difference between the machine part and the required part. It's about 0.016 of inch. So I need to make another operation to machine that difference. That feature will be added manually. And like I said, it's a manual added feature. So the last point I was talking about is that the simulation shows us the path that we are going to cut through it. And show us as well the difference between the resulting from our machine, the resulting part for our machine, and the original part I want to continue with. So I'm going to add a feature manually. So going to 2.5 axis feature and select it. I will choose a pocket in as a feature, select the required face for machining, and for strategy, select rough finish. Then assign the end condition, use it up to stock, and make sure that it will cut to the stock or the final product I want to. Next step is island and make it auto select, and that to avoid any collision between the work tool and our part. So as I made the facing operation recently, you will find it below the tree. I will drag it up the list with the contour cutting operation to make SolidWorks start with these features while generating my code. Drag and drop now, and more sorting operation, I will have the ability to sort so many operations according to a certain parameters. In this case, the parameter will be the operation type. So with clicking yes, you will find the operations are sorted according to the operation type, which will reduce the time of changing the tool between during the operation, and that will reduce so many time. Also, I will combine the operations with one tool to one operation, and that to avoid the tool to return to the zero after each step. It would continue line by line. After we have done some optimization to the toolpath, let's simulate the motion, and don't forget to compare between the results. The final machine part is giving an acceptable results, except for the lower side of the workpiece, because it's mounting to the vise and we need to make another operation with the part is flipped. Now I have done the first section, and it's about the fixtures. We have seen how easy SolidWorks CAM to use because it depends mainly on the AFR, or the automatic feature recognition, which can recognize the machinable feature automatically. And then SolidWorks will convert those features to operations. We only need to edit and customize SolidWorks database for one time, based on our workplace nature, such as tools, feeds and speeds, the machine part, my operational machine, post processors, and so on. Also, SolidWorks CAM automatically assign the operation with tools to cut each feature he recognizes, which would also reduce your time so many. We always say that SolidWorks CAM is a feature-based, not an operation-based, because it's easier to recognize one feature and then automatically introduce the cutting process necessary for it. So with only 3 clicks, we can generate NC code for any part, which reduces the programming time and make it easier to use. So after the fixtures and part programming, now I'm going to the third part in our webinar, or third section in our webinar, and that will be the high-speed machine. And I'm going to introduce a new technology called volume mill for roughing operation. But before I will start the volume mill technology, let's see how far the audience, what's your expectation with the high-speed machining to reduce your time?
So for anyone of the audience who's familiar with the high-speed machining, so what's your best expectation? What do you expect from high-speed machining? Is it going to reduce the machining time by 10% or 30% or maybe more than 50%? So consider the high-speed machining is just a way to reduce the machining time. So actually, this is our ultimate goal. Okay, so let's close the poll, share the results. So most of our audience today, Mahmoud, they are expecting 30% machining reduction, machining time reduction.
Excellent. So, okay, that's a good start. So let's see how could volume mill technology reduce our machining time. So we are going to use SolidWorks CAM high machining speed to achieve 3 points, which are reducing time machining, or reduce machining time, and increasing the tool life, and increase the productivity. For traditional method in SolidWorks CAM, you will find that part will take 42 minutes on the machine. So I will press OK and check each feature separately. If I took a look on the contour cutting operation, edit definition it, and check that time, you will find that it will take around 40 minutes. So going to use volume technology and watch its advantage. I don't want to change the strategy. I only want to change the way of dealing with wrapping operation. Also, I will use the volume expert. And volume experts will help us to adjust feeds and speeds according to the material, tool type, and the material coating, and so other parameters. So after I have done that, I will explain how volume technique is working. It's increasing the depth of cutting and reducing the step over, which means the whole end mill will cut with the full cutting edge. So that's a good advantage. So we kept the strategy as it was. Let it process and check the final time. If you noticed the new path, the new tool path, you will find that there is no sharp corners, or as it called, the positive slope. Also, volume technology changes the feed rate according to the geometry of the tool, which will reduce the load on the cutting tool. Now let's check the final time, the final machining time. Okay, it's around 1.5 minutes. It's roughly 1.5 minutes, which means it's a reduction of 90% of the cutting tool operation. And that's a very good percentage. I will repeat that step with the facing wrapping operation. Check the time. This operation is taking around 40 minutes. So changing the pocket in to the volume mill. And adjust the rest of the options to my needs. I will go to the volume mill expert, add more aggressive, and go back to check your time. So optimize, check your time, it's around 2 minutes. After it was 14 minutes, it's around 84 or 85 time percentage. So the first operation is 90%, and the second operation is 85 time reduction for the operation with the most time consuming. Now let's do something called step-through toolpath to check each parameter, such as feeds and speeds for each step. You will find that the feed rate is automatically changing with the time to keep the load stable on the cutting edge. And that will keep the material mover rate is stable as well. Now, as a final machining time calculation, you will find that it became 17.5 minutes instead of 41 minutes, which means we reduced the machining time to 58%. That's only with using volume technology. We didn't change anything about the machining strategy. So with numbers, volume had achieved a good reduction to the machining time, which is really useful to me, and that to get my work done quickly and more accurate. It's a 58% of time reduction. So as a quick briefing, we had mentioned some strong points on the volume. It's a faster machining time, cut faster and deeper. It's increasing the tool life, and that's by changing the feed rate to keep a constant pressure or a constant load on the tool. Give less stress on the machining, and the variable feed rate also reduces the wear on the machine. It's compatible with all machine tools. You can run volume toolpath on any machine tool, high or low end, although the machine will need to be capable of running a high-speed spindle in order to see the benefits of volume technology. So after I have done with the high-speed machining, I will go to the fourth section, is the design change. Before that section, I need to ask something. How many times do you experience design change per project? 1 time, 2 times, 3 times, or more?
So maybe some of us will be doing a regular design, a common design, so you're not expecting that much of design changes. However, some of us are working with R&D, So you are expecting a huge amount of design changes. So let's see. Okay, let's give you a couple of seconds. And closing the poll, sharing the results. So most of our audience today, they have more than 3 times design changing, Mahmoud.
Wow, that's the most challenging part in your design or in your CAM project. Okay, I will tell you now how to reduce the efforts of that process. So now we are going to see how SolidWorks can deal with the designs modification and how it could relate with the toolpath which already exists from the original process. So now let's see how could SolidWorks can deal with the design change, which always happens. So simply, I will open the part and make any CAD modification. Change any radius, fillet radius, any depth, whatever the changes you would like. And then after that changing or the CAD modification, return to the assembly environment. When you activate the CAM tab, you will find a message, and that message is saying that there is some CAD modification or toolpath modification happened, and if you would like to revert that according to your CAD modification or not. If you said yes, then the whole project or the whole programming will rewritten according to the new modification, which means you didn't do anything to your project. It's only one click, and that click changes all your programming line. So after we have done the updates, let's generate our NC code. That NC code is generating according to the post processor you initially chosen from the machine selection window. So press play or run. And go and open your code. So here we can read the NC code line by line. Additionally, we can open that with NC editor if you would like to delete, edit, and do whatever you want from your programming line. I don't want to do any changes. I will press OK and save and go to send that to the machine directly. So now we have seen how SolidWorks could provide us with associative environment between CAD and CAM. So simply, after we made any changing to our CAD project, you will find the CAM environment update the toolpath and the code according to these changes, which help us to reduce time, and we don't need to repeat the whole steps or the whole procedure again from the beginning if we added any kind of modification. So after we have done the 4 steps in or the whole section or the whole process in our CAM projects, I'm now done with the CAM webinar. So I have finished that webinar, and I will be glad to accept any question from your side if you have something to wonder.
Thank you so much, Mahmoud. I think it was a very informative session from your side. You give it a lot of insight about SolidWorks CAM and how to machine our parts, our designs.